In this video, I'm going to talk about momentum and its conservation. You already know what is momentum. It is a product of mass and velocity with a unit kg/meter per second, and it is a vector quantity with direction along the direction of velocity. Now, let us talk about its conservation. Consider two colliding objects, a ball of mass m1 moving with velocity u1 and another ball of mass m2 moving with velocity u2 in the opposite direction. Assume that the surfaces are completely frictionless. When the objects collide, then they exert force F1 and F2 on each other during their time of collision delta t. Now, after collision, they will move in opposite direction with different velocities v1 and v2. Now, if we talk about what happened during collision, then m1 exerted force F1 on m2 while m2 exerted force F2 on m1. According to Newton's third law, these forces are equal in magnitude and opposite in direction. That is why we have the negative sign here. Now this force was exerted for a time interval of delta t. So if we multiply delta t on both sides, then F1 delta t equals to negative F2 delta t. According to Newton's second law, force into time interval equals to change in momentum. You already know that, right? Therefore, change in momentum for particle 1 will be equals to negative change in momentum for particle 2. So if you write m1 v1 minus m1 u1, that is a change in momentum for particle 1, that will be equals to negative sign as it is change in momentum for p2, m2 v2 minus m2 u2. Let us simplify this. So m1 v1 minus m1 u1 equals to, we multiply the negative sign inside, minus m2 v2 plus m2 u2. Then rearranging this, we get m1 u1 plus m2 u2 equals to m1 v1 plus m2 v2. If you have a look at this equation, then everything on the left side is the total momentum before collision, and that is equals to, all the terms on the right side is nothing but total momentum after collision. So keeping this in mind, we can state the law of conservation of momentum. In absence of external forces, the total momentum is always conserved. So total momentum before will always be equal to total momentum after. Now here, I didn't say before collision and after collision because in different questions you will have different scenarios, like a man jumping from a boat. So as the man moves forward, the boat goes backwards. Or a rifle from which a shell is fired. So as the shell moves forward, the rifle recoils. Or simply, a truck moving collides with a car and they both move together as one object. So you apply the conservation of momentum in general depending what arrangement is given in the question. Let us see one example. The muzzle velocity of a 30-gram shell leaving a 5 kg rifle is 200 meters per second. What is the recoil velocity of the rifle? So you have the rifle, and when it is fired, the bullet moves forward and the rifle recoils. You have to find the recoil velocity of the rifle. So here you have m1 30 gram, convert that to kg, so 0.03 kg. v1 velocity after it is fired, so you take it as v1, is 200 meters per second. Mass of the rifle m2 5 kg, and you have to find the velocity of recoil. Here the initial velocity of the rifle and the shell together, they both were at rest before it was fired. Therefore the initial velocity for both of them is 0. So simply there total momentum after is equals to 0, right? So rearranging this equation, I get V2 equals to minus m1 v1 by m2. Substituting the values and simplifying, I get the answer as minus 1.2 meter per second. The negative sign here indicates that the direction of recoil will be opposite to that of the direction of the shell. Now it's your turn. Try this. 800 kg car has stopped at the traffic light. A 1200 kg truck moving at 8 meters per second collides with the car and their bumpers lock. Calculate the velocity with which both vehicles will move. So here you have to understand that only the truck had the initial momentum, and after collision both of the vehicles will now move together as one object. Solve it and leave your answers in the comments.